Welcome to Understand the Math. Today I'm going to teach you how to find the equation of a line in slope-intercept form, point-slope form, and in standard form. We'll walk through example problems, talk about when to use each form, and how to convert from one form to another. Be sure to check out the link below for free guided notes that you can use while you watch this video. There's space in the notes for you to highlight the formulas and steps that we'll go over and fill out the answers to the examples that we're going to do. This way, you'll have a set of notes to refer back to when you need to review this concept again or study for a quiz or an exam. The first form for an equation of a line that we'll look at is the slope-intercept form given by the equation y is equal to mx plus b. This is the form that you'll need to use when you're given a slope m and a y-intercept b. This is a convenient form for graphing a line because you know the slope and where it intersects the y-axis, making it easy to visualize. Let's quickly go over where this equation comes from so that you can better understand it. Recall that the slope of a line is equal to the rise, how much the line changes vertically, divided by the run, how much the line changes horizontally. This is often written as delta y divided by delta x. Let's calculate the slope of this line and look at the change in y and in x between a point on the line and the y-intercept. M is equal to the change in y, which is y minus b, all divided by the change in x, which is x minus 0. Let's now solve this equation for y. We'll multiply both sides of the equation by x, and we'll get mx is equal to y minus b. We'll then solve for y and get the slope-intercept equation y is equal to mx plus b. Let's now look at an example. We want to find the slope-intercept form of the equation of a line that has a slope 2 and a y-intercept 3. I've written down the two steps that we need to complete. We first need to write the equation and then plug in m and b. Let's go ahead and do that. We have y is equal to mx plus b, and then we'll plug in values for m and b. This gives us y is equal to m, which is our slope of 2, plus b, which is equal to 3. I've graphed this line on the right-hand side so that we can better understand the equation. Our line intercepts the y-axis at the point 0, 3 and has a slope of 2. If we write our slope as being equal to 2 over 1, we can visualize it as a change in y of 2 and a change of x of 1. The second form that we'll look at is the point-slope form given by the equation y minus y1 is equal to m times x minus x1. This is the form that you'll need to use when you're given the slope and 1 point on the line, and also when you're given 2 points on the line and not given the slope. Let's quickly see where this formula comes from. Let's say we're given 2 points on the line. The first point is xy, and the second point is x1, y1. Our slope is equal to the change in y divided by the change in x, and that's equal to y minus y1, all divided by x minus x1. If we multiply both sides of this equation by x minus x1 and flip the sides, we get the point-slope form equation y minus y1 is equal to m times x minus x1. Let's now do two examples. In our first example, we'll find the point-slope form of the equation of a line that has a slope 3 and passes through the point 2, 1. I've written down the 2 steps that we need to complete. We first will write the equation, and then we'll plug in our slope and our point x1, y1. Let's write down our equation. We have y minus y1 is equal to m times x minus x1. We'll then plug in our slope, so our m is equal to 3, and our point x1, comma y1 is equal to 2, comma 1. Let's now plug these into our equation. So we have y minus y1, which is equal to 1, is equal to our slope, which is 3, times x minus x1, and x1 is equal to 2. And this is our equation in point-slope form. To visualize this line better, let's convert it to slope-intercept form. This will also give us practice in doing these types of conversions. We'll bring the 1 to the right-hand side, which gives us y is equal to 3 times x minus 2 plus 1. And then we'll go ahead and multiply things out on the right-hand side and combine terms. So we have y is equal to 3x, and then we have a minus 6 plus 1, which gives us a minus 5. We can see that this matches up with our graph of the line on the right-hand side because our line has a slope of 3, the change in y divided by the change in x, and it has a y-intercept at minus 5. In our second example, we're going to find the point-slope form of the equation of a line that passes through the points 2, 1 and 5, 3. The first step that we need to do is write the equation. We'll then find the slope using the formula m is equal to the change in y divided by the change in x. And then lastly, we'll plug m and our point x1, y1 into the equation. On the right, I've graphed our line and the 2 points that it passes through. We need to label one of these points x1, y1 and the other one x2, y2. It's common to let the point on the right be equal to x2, y2, and the point on the left to be equal to x1, y1, because it's easier to subtract a smaller number from a bigger number. We'll start with writing our equation y minus y1 is equal to m times x minus x1. Our m is equal to y2 minus y1, all divided by x2 minus x1. This is equal to our y values, 3 minus 1, all divided by our x values, 5 minus 2. And this is equal to 2/3. Let's now plug our slope and our point x1, y1 back into our equation. So we have y minus y1, and y1 is 1. And this is equal to our slope, which is 2/3, times x minus x1, and x1 is equal to 2. Let's now write this equation in slope-intercept form so that we can see what the slope and y-intercept are. We'll begin by moving the 1 to the right-hand side. So this gives us y is equal to 2/3 times x minus 2 plus 1. Let's then multiply everything through on the right-hand side. So we have 2/3 x minus 4/3 plus 1. And that gives us a final answer of y is equal to 2/3 x minus 1/3. We can see on our graph that the y-intercept is minus 1/3. The last form that we'll look at is standard form, given by the equation ax plus by is equal to c. It's a requirement in this form for a and b to both not equal 0, and a is usually greater than 0. This form is used for solving linear systems of equations. and it's a convenient form for finding x and y intercepts. Equations in slope-intercept form or point-slope form can be easily converted to standard form. To see how you can easily find intercepts from this form, we can let x equal 0 and solve for y in this equation, and we get y is equal to c over b, which is the y-intercept. Likewise, we can set y equal to 0 in our equation, and we get x is equal to c divided by a, which is our x-intercept. So when you need to find the y-intercept, you set x equal to 0, and when you need to find the x-intercept, you set y equal to 0. In our last example, we'll convert the equation y is equal to 2/3 x minus 1/3 to standard form. This is the equation that we got in our second example on the previous page. The steps that we'll use to convert the equation is to first write down the standard form, then eliminate any fractions, and then third, move the terms around to get the equation in standard form. And then our fourth step, we often don't need to do, but it's to make sure that the coefficient multiplying x is greater than or equal to 0. Let's first write down our equation in standard form. That's going to be ax plus by is equal to c. In our second step, we'll first write down our equation. Y is equal to 2/3 x minus 1/3. To get rid of the fractions, we'll multiply both sides of the equation by 3. So we have 3y is equal to 2x minus 1. For our third step, we'll move the terms around so that the terms end up in the same order as they are in standard form. Let's first move the 3y to the right-hand side. So we have 0 is equal to 2x minus 3y minus 1. And now let's move the minus 1 to the left-hand side. So we get 1 is equal to 2x minus 3y. And then we'll rewrite our equation as 2x minus 3y is equal to 1. I hope that you now have a better understanding of the 3 different forms that you can use to write an equation of a line, and now feel ready to work some example problems on your own.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.